Sometimes a picture is worth 1,000 words, and sometimes just looking at the data gives you great insight. We're going to look at the data for coronavirus day by day across every country with 10 million or more people and across the 20 most populous US states. We're going to look across two dimensions. On the scaled x-axis, total deaths per million as of that date. On the scaled y-axis, the approximate death rate on that day in deaths per million per day. This is how COVID progressed. When you look at all the data across every country and every state, three things strike you. First, deaths always seem to decline once the epidemic has reached 300 to 600 deaths per million. Second, once a geography has reached a level of high exposure, it is never taken off again in a sustained way. And third, the 20 largest US states appear to be nearing a point of high exposure. The question is, does any of this matter? The answer is yes. Accepting the points that this presentation is going to demonstrate has profound implications on every societal decision regarding COVID. If you accept what's outlined in this presentation, it should impact your perspective about the trade-offs involved in decisions about schools, colleges, businesses, and life in general. But before getting started, three introductory points. First, my name's Anthony Bruce. My business is data analytics. I've held positions including president, applied analytics of a Global 2000 firm, co-founder and CEO of a cloud-based predictive analytics company. Second, throughout this presentation, I'm going to be using the term community exposure impact rather than herd immunity. The mathematical assumptions behind standard herd immunity calculations assume two things. One, that all people behave the same way, and two, that all individual susceptibility is one of either two levels, immune or not immune. If these two assumptions are violated, as they are with COVID, the standard herd immunity equations break down. The causes of community exposure impact are far more nuanced and require neither widespread immunity nor large-scale infection of the herd. Third and finally, when I refer to something changing when we observe X number of deaths, this is a communication shorthand along two dimensions. First, deaths are being used as a proxy for infection levels. And second, the infection mechanisms that are driving changes in deaths occur roughly 2 to 4 weeks prior to deaths. With that, let's get started. The first effect is that we always see declines in deaths start once an area experiences 300 to 600 deaths per million. If you put this data that you saw into an AI or machine learning or some other model, the most dominant and the most confident variable, most dominant coefficient that comes out is the level of infection. It's this. But the question is the variable causal? Is it because infection levels have reached at a certain point that declines begin? Or is it just correlated or coinciding with other actions that are occurring at the same time? Stay-at-home orders, behavioral changes. The best way to know is to run a test or an experiment, to hold all other variables constant and observe what happens when the only change that's occurring is community exposure. This has actually happened. It's happened several times. There are three clear examples: Arizona, Florida, and Texas. Until this summer, many restrictions were in place in these states and many businesses were closed. COVID deaths, as you can see, have been slightly increasing since the shutdowns. But after businesses were opened, there was a dramatic increase, both of cases and of deaths. The week-over-week peak in gross in deaths in these three states came within a 5-day period in early July. 90% growth in Arizona, 86% growth in Florida, 125% growth in Texas. But the decline in deaths began at different points. On July 18, Arizona reached 375 deaths per million, and it started to decline. 2 weeks later, on August 2nd, Florida reached 330 deaths per million, and deaths began to decline. A week and a half later, on August 11th, Texas reached 321 deaths per million, and deaths began to decline. So these declines are the same declines we see in every other state and every other country, but what's different here is that there were no other changes. Community exposure's impact is isolated. During this time period of 8 weeks, not only do we see major acceleration followed by major decline, there weren't other changes. There were no governmental interventions. Attitudinal studies didn't change in terms of opinions in these states about masks or protective measures. There were no declines in mobility measurements after opening up. It was not that 2 to 4 weeks before the peak in deaths that the population shifted its behavior to become more protective. If anything, the behavioral data suggests the reverse. Solely because of community exposure impact do we see these declines. The implication is that changes in exposure created as much as a 70% reduction in transmissions, a 70% reduction in R0. Of course, for a long time, we've had another example of what happens when COVID is managed in a laxer manner. Sweden took a different approach than Denmark and Norway. It closed its borders, managed more aggressively the virus, and are still at a point of fewer deaths and fewer infections. Denmark and Norway may prevent infections for long enough that a vaccine becomes available. One can certainly critique Sweden's approach. But the experiment in Sweden does reconfirm the effect of community exposure and reconfirms and shows the same patterns that we observed in Arizona, Florida, and Texas. It provides similar evidence that community exposure reduced transmissions by 70%. We even observed community exposure in the timing of the declines in U.S. lockdowns. Consider New York, Massachusetts, and Illinois. Each of these states, around a 3-day period of around March 20th, issued stay-at-home orders or their equivalent. And the impact of those orders, as judged by mobility data from the Dallas Fed, indicates that there were similar changes in behavior. See the bottom left. And yet the first of these geographies to decline, indeed the first geography in the U.S. to decline, was New York on April 10th. Stepping back, you'd expect New York to be the last place you would see declines. Public transit remained open, there's dense multi-generational housing, but it was the first. Let me be clear. Awareness reduces transmissions. Masks reduce transmissions. Stay-at-home orders reduce transmissions. Social distancing reduces transmissions. But what was simultaneously occurring in New York around this time was that community exposure was applying an additional braking force on the spread of the virus. On April 10, New York had experienced 522 deaths per million, and deaths began to decline. On that same day, Massachusetts had only experienced 86 deaths per million. Despite similar non-essential business closures and similar mobility changes, this likely easier to influence geography continued to grow in deaths until April 26th, when Massachusetts reached 421 deaths per million and then began to decline. On the same day when Massachusetts began to decline, Illinois had only experienced a little over 100 deaths per million. And again, despite similar non-essential business closures and similar mobility changes, deaths in Illinois continued to increase until May 10, when Illinois reached 270 deaths per million and then began to decline. There are many drivers of transmission decline, but community exposure is particularly powerful. One thing of note before we leave this slide, steps taken early make a big difference. As could be seen in the time-lapse video, the higher the peak in deaths reached per day, the higher total number of deaths observed. Sweden, Arizona, Texas, Illinois, others reached peaks of 7 to 11 deaths per million per day and reached similar points of total deaths. Like in northern Italy and in Wuhan, New York City continued with behaviors that were unaware of the disease early on and reached a higher peak, 80 deaths per million per day. Had awareness occurred earlier, the peak would have been lower and the total deaths would have been fewer. Acting 1 week earlier would have saved lives. So point one's been demonstrated. Community exposure drives decline. What about the observation that when high exposure has been reached, there's never been a reignition? The statement's accurate, but it sounds contrary to what you hear covered in the press. In fact, there have been many examples of openings, releases of restrictions, eliminations of mandates in high exposure geographies that have not resulted in sustained increases in hospitalizations or deaths. Community exposure is also dampening reignition. What's an example? Let's look at the United Kingdom. Pubs opened on July 4th, and there was a lot of concern from many that this would ignite a second wave of hospitalizations and deaths. Let's be clear. Indoor restaurants, pubs, nightclubs, these are transmission paradises for this disease. But due to prior community exposure, the United Kingdom saw no increases. But we keep hearing about second waves. Why? Generally, it's because of a misread of this graph and others, which receive a lot of media coverage. This is a graph of cases. Measures of cases, or positive tests, are not measures of infections. The data and how the data was collected on the left-hand side of this graph is different than the data and how the data was collected on the right-hand side of this graph. Early on in Spain, cases likely understated infections 25-fold, meaning for every case there were 24 or more other infections not identified as a case. Case numbers in Spain were being reported from hospitals, complemented by positive tests as available, but the average age of a case early on was 60 years old, not because that was the average age of an infection for someone with an infection, but because the data collection method was heavily biased towards patients in hospitals. Now, the understatement of cases versus infections is likely around 2 to 3-fold. Widespread testing is much more available. So when you adjust the graph to estimate infections, infections look more like this. In fact, the case data adjusted to estimate infections looks similar to the pattern of deaths in Spain. But there's clearly a, albeit smaller, second set of hospitalizations and deaths. Why is that not a second wave? So in geographies like Sweden that never locked down, we don't see such a second rise. But as will become even more clear when we walk through the US experience, in countries where lockdowns occurred, there were some parts of those countries where community exposure had not reached a level sufficient enough to have an impact in reducing transmissions prior to the lockdowns. So in Spain, there were some villages, regions, neighborhoods, suburbs, and larger cities that had only been partially exposed when the lockdowns were put in place. In fact, you can observe there's a correlation between less infected geographies prior to lockdown and where these additional deaths are occurring in Spain. But critically, as can be seen in infections, in these second geographies, the rise has begun to flatten. The rise is no longer accelerating. So we would expect these continued smaller rises due to lack of community exposure not to occur in locations like Sweden that didn't lock down, and they don't. They should be most significant in countries with fewer infections to date, fewer deaths to date, like France. And as we see, been significant, there will likely be an uptick in deaths in France. They should be less so impactful in England or Italy, or like we saw Spain, and still less so in a New York or a Massachusetts. Unfortunately, a misinterpretation of this phenomenon and the misleading graphics that are reporting cases in Europe puts Europe at risk of disproportionate reactions to these less substantial increases in infection. So stepping back, community exposure is causing declines and limiting reignition. Due largely to this effect, no country with greater than a 50,000 person population has experienced 1 in 1,000 people dying. That includes countries with haphazard management of the epidemic, such as Brazil. So why is that? Well, there are many theories as to why, but I want to distinguish between a theory and a data-driven conclusion. In terms of theories, some believe that far more people have been infected than is reflected in the number of people testing positive for antibodies. Some people believe in immunological dark matter. Some people believe that T-cell immunity is central to the observation of this effect. I believe more generally that the dynamic of heterogeneity and susceptibility is important in driving this effect. There are many theories as to why, but the fact that this occurs, the fact that community exposure is suppressing transmission is not a theory. It's a data-driven conclusion. So what about the third point? The fact that the 20 most populous states are nearing a high exposure zone. What does that mean? That means in the US, we're going to continue to see declines in infections and deaths in a way that both will soon reach a new low. Many may find that prediction surprising. Many people's views of how the pandemic is progressing progressing are misinformed by or because of a misinterpretation of this chart. People look at this chart, it's a chart of US cases, and they misperceive that there were more infections in July and August than there were in March and April, and that the level of infection today is higher than it was in March and April. Why? Because that's what the chart looks like. But just as we saw before, this is not a chart of infections. It's a chart of positive tests predominantly. And in fact, infections were lower in July and August than in March, April, and we're nearing a new low. How do we know? We know because of the patterns we see over time from antibody tests that are conducted by the CDC and others. CDC has conducted a number of antibody tests to determine the degree to which cases or positive tests understate infections. In this example from May in a region near New York, 23% of randomly selected people who were tested positive for antibodies. Given the size of the population in this region, the CDC estimated that 2.8 million people had been infected. That compared at that time to 281,000 cases being reported. So at least in this instance, the CDC concluded that cases were understating infections at least tenfold. It's in part because during this period, testing was difficult to obtain. So 9 out of 10 individuals that were infected with the disease never tested positive for the disease. Testing availability has changed a lot since March and April, so it shouldn't be surprising that the antibody tests conducted over time by the CDC suggested that the understatement of cases to infections is becoming smaller and smaller, from 11-fold to 10-fold to 7-fold to 4.5-fold. So today there's much more widespread testing, and the number of cases are closer to the number of infections than they were in the past. So what's the implication? Well, if we take the number of cases from the graph before and we multiply it by the degree to which cases understate infections over time, we can estimate the number of infections over time. And what we see is that the peak of infections in July and August was lower than the peak of infections in March and April, and that we're nearing a new infection low. The pattern of infections once estimated also looks similar to the pattern of US deaths. Also, looking at deaths segmented by geography highlights that there has not been a second wave in the United States. In highly exposed geographies in the blue line, like in the Northeast, Illinois, Louisiana, Michigan, there have been no sustained increases. Recent increases in deaths have been driven by Florida, California, Arizona, Texas, and Georgia. Looking more broadly across geographies, the U.S. should reach a new low in deaths roughly over the next 3 to 4 weeks. So will these patterns continue? Well, there are two concerns. The first, and very important and problematic, is that all the math changes if there are widespread reinfections. Individuals who recover from the disease that contract it again and become transmissive again. We haven't seen that globally at scale, but we could. And if we do, it would change the patterns. The second is possible. I believe it's less likely. Absent reinfections, could a change in weather or associated behavior from a change in weather create a change in infection dynamics? So one reason that influenza is seasonal is because the influenza virus does not survive warm weather well. This in part drove the multiple waves across years of the experience in the Spanish flu epidemic. COVID appears more robust across weather conditions, but regardless of my opinion or others' opinion, our conclusions and actions should be driven by the data. We should be looking for these two potential changes. In Stockholm, the temperature is nearing freezing already. We should monitor and we should see if a seasonal spike begins absent reinfections. More generally, we should be looking the world over for the potential emergence of widespread reinfections. But absent seeing such data, we should be confident that these patterns will continue. So community exposure drives declines. It dampens reignition. And across the United States, much of the country is at a point of high exposure. So what does this mean, and should it influence our decisions? It should influence every decision in geographies where we are at high exposure in particular. All decisions involve trade-offs. For any decision on the one side is increased safety from the possible reduction of transmission. On the other side, something else, from the societal imperative of educating our children for their future, to ensuring timely screenings for cancer and other diseases for our population, to the more mundane of increases in comfort by hiking on public lands without a mask. So this belief influences all decisions about COVID. Some people would have you believe that the US is on the precipice of an additional 200,000 deaths. The implication would be that we're on the precipice of an additional 600 deaths per million people. As I bring you back to the time-lapse data that we started with, ask yourself this question. Is that claim credible? Given what we've seen in Sweden, given what we've seen in reduced transmissions in Florida and Texas and Arizona despite a lax approach, given the experience of Brazil, where death levels have plummeted, is there persuasive evidence for such a claim? Sometimes a picture's worth 1,000 words, and sometimes just looking at the data gets you to the right answer.